Well-known technologies, radar and sonar, were developed during World War II for the same purposes, finding distant objects in the air or at sea while estimating their distance and speed. LiDAR does the same, but using lasers, allowing the user to resolve distances and speeds with more precision, as well as making it easier to find smaller objects. Pulsed LiDAR measures distances by measuring the time of flight to an object. Light is emitted from the LiDAR source, travels to an object, reflects off that object, and travels back. The time it takes for the light to go back and forth is the time of flight, which is directly related to the object's distance. Fortunately, time of flight measurements are easy to make. However, the accuracy of these measurements is limited. Pulsed LiDAR can also estimate the speed of distant objects. This takes at least 2 LiDAR pulses because an object's velocity is measured by determining the time lapse between the pulses. The problem with measuring speed this way is that it takes an excessive amount of time. However, frequency modulated continuous wave, or FMCW LiDAR, sends out a continuous, not pulsed laser signal to the object. The frequency of the beam is modulated in an up and down pattern, or what we call chirped. The combination of a continuous beam and known frequency modulation pattern gives you an easy way to measure distance by comparing the frequency of the reflected beam with the frequency of the original emitted beam. In short, while time-of-flight LiDAR measurements are easy to perform, the technology has some major drawbacks and limitations, especially where speed and accuracy are required. Aware of these drawbacks, SVI developed and patented a method for overcoming them: dual chirp FMCW LiDAR, or 4D LiDAR. SVI is the owner of the original patents as well as the overriding patent families in this technology area. What is dual chirp? Dual chirp refers to sending 2 LiDAR beams at slightly different frequencies and times. The 2 beams provide separate measures of an object's distance, which can be used to instantly and accurately measure the object's speed or velocity simultaneously. There are a wide range of practical applications for SVI's LiDAR, including 3D facial recognition, driverless cars, heart rate and breathing rate detection, 3D gate detection, robotics, and industrial metrology, to name just a few. Furthermore, SVI continues to lower the cost of our FMCW 4D LiDAR system, looking to realize our 100+ worldwide patents and patents pending onto a single silicon chip. SVI technology can assist in solving your technology problems in the most innovative and cost-effective ways.